All right, so we've got a third rational function example here. F of x equals 3x minus 6 over x squared minus x minus 2. And of course, the first thing we should do here, because we do see a common factor up top, is to factor out that 3. And we might as well go ahead and factor the denominator. We know we're going to have to do that. And so we see here that we do have a common factor top and bottom. So we're going to cancel that thing out, but we're going to remember that that makes a whole, right? But now we have what's called our reduced function, 3 over x plus 1. So this is our reduced function. And this is really the graph of x plus 1, and 1 over x, sorry, but shifted 1 to the left and stretched, right? So this is the graph of 1 over x shifted 1 left and stretched by a factor of 3. Okay, so what's our domain on this one? We are going to have to throw out -2 because there's a hole there. We know that. Sorry, +2 and -1. All right, what about our y-intercept? Well, when we plug in x equals 0, we're going to get 3. We'll go ahead and plug in the whole thing. So it doesn't matter if you plug into the reduced function here or the original function. You should get the same value either way. So we would have 3 times 0 minus 6 over 0 minus 0 minus 2. That's going to give us 3. So our y-intercept is at 0, 3. We can go ahead and mark that right there. And we know we've got a vertical asymptote at x equals, don't forget the x equals, right? X equals -1. Of course, my scale on this, I'm going to mess with my scale because I forgot to fix it. Because I used the one from the previous problem. All right, there we go. So we have a vertical asymptote at -1. Of course, I can't do straight line to save my life. And we also know that we have a hole at x equals 2. Now, what is the actual value of the hole? It's going to be what we get when we plug into the reduced function. So that would be 3 over 2 plus 1, i.e. 3 over 3. So our hole is going to happen at 2, 1. So I'm going to just put myself a little open dot there, right? And are there any x-intercepts? No, there's not any because our numerator is just a 3 in the reduced function. So it's not going to be crossing the line. We also know that it should look like the graph of 1 over x. So we can kind of do this. And then let's see if we can kind of do the same here. So roughly speaking like that. Okay. And again, we are going to check that with GeoGebra. Let's get the GeoGebra up. All right, so we're going to put in our original function here, 3x minus 6 over x squared minus x minus 2. And you can see that that basically looks like what we had. We're going to have that vertical asymptote at -1. And here's the question, because you can't see the hole on here, even if we stretch it, although I think I just saw it mark it there somehow, right? So, but we can ask, we can say, okay, this is a g function. What is g of 2? It's going to tell us undefined. Okay, and I also notice that when I click on the formula for my graph, it is going to make a note of that hole that we found at 2, 1. All right, so that's it for this example. I think we have one more coming up before we start talking about, I think, horizontal asymptotes.